Today we're going to graph the sine curve, and hopefully from last week you picked up a few vocabulary words that'll help us as we graph the sine curve. Most importantly, we're going to use a word called midline or axis of rotation, and that refers to the middle of the graph in the y direction. So we literally want to split the graph into a top half and a bottom half, and wherever that happens to be would be called the midline or axis of rotation. Once we establish what the midline is, that will be easier for us to see the amplitude. The amplitude is the distance from the midline to either the maximum or the minimum. So this is the amplitude, and so is this. It is not the difference between the max and the min, but it is simply the distance from the midline to the max or the min. It's always positive, no matter which direction you're going. And one way that we can find the amplitude is to take the maximum, subtract the minimum so we can see the difference, and then divide that by 2. That also gives us a way to find the midline. The middle is like a midpoint, so we could do the max y value plus the min y value and divide by 2. The period is about x, the length of the interval of the domain to complete one cycle. Essentially, we have to go through the entire set of values that the graph covers and get back to the starting point. So we started here at a value of 0, we cycle through positive values, we go through negative values, and now we're back at the beginning and we can see the pattern start to repeat. So however long that takes in the x direction would be called your period. So to better understand the sine graph, we're going to look at these values from 0 to 540 degrees. All of these should have easy to graph sine values. They should all correspond to a reference angle of 30 degrees or a quadrantal angle. So just to get us some extra practice, these are in degrees. We're going to convert those to radians. Hopefully now we're comfortable knowing that 90 is pi over 2. 150 is 5 pi over 6. 180 is half of a rotation, or pi. 210 would be 7 pi over 6. 270, that is 3/4 of a rotation, which is 3 pi over 2. 330 is 11 pi over 6. And at 2 pi, we've come all the way around the unit circle, and we're back at the positive x-axis. Then if we go 30 degrees beyond that to 390, that is 13 pi over 6. 450 degrees, we're back at the positive y-axis, which is 5 pi over 2. 510 degrees is 17 pi over 6. And 540, we're back at the negative x-axis, 9 pi over 2. All right, so sine is the y-coordinate as we go around the unit circle. At our 30-degree reference angles, it's going to be 1/2. It might be positive or negative depending on the quadrant. And at our quadrantal angles, it's either going to be 1 or 0. So when we get to 90, the y-coordinate on the unit circle is 1. We're going up an entire radius. 150 degrees is 5 pi over 6. That's in the second quadrant where sine is still positive. That's a 30-degree reference angle. Sine is 1/2. At pi, we are at the negative x-axis. So we haven't gone up or down. The y-coordinate there is 0. 7 pi over 6, that's our 30-degree reference angle in the third quadrant. In the third quadrant, sine is negative. The y values are negative, so this is negative 1/2. At 3 pi over 2, we are at the negative y-axis, and that means our sine value is negative 1. 11 pi over 6, that's a 30-degree reference angle in the fourth quadrant. Y values are negative in the fourth quadrant. This is negative 1/2. You can see all these are pretty easy to keep track of. At 2 pi, again, we're back where we started, so we're back at 0. 13 pi over 6 is just 30 degrees beyond that. It is coterminal, stops at the same place as 30, so that means its value is also 1/2. 450 is coterminal with 90. That's the same as pi over 2 or 1. 17 pi over 6 is coterminal with 150, so that's 1/2. And hopefully you can start to see the pattern here. 9 pi over 2 is coterminal with 180. We're at the negative x-axis, and our y value for sine will be 0. So these should be pretty easy to graph. You'll notice in this function, y equals sine x, your x coordinates are the angles. The y coordinates are the sine values of those angles. So on the x-axis here on this graph, we have our radians, corresponds to the radians here in the table, and then our y values, how far we go up or down will depend on that second row in our table. So let's plot these points, and then we're going to connect them with a smooth curve because this is a sinusoidal function. Our first point is 0, 0, and then at pi over 6, we're at 1/2. Over here at pi over 2 up to 1, 5 pi over 6, and pi is at 0. Going to 7 pi over 6, now we're at negative 1/2, so we're going to go below the x-axis and plot negative 1/2. At 3 pi over 2, we're at negative 1. At 11 pi over 6, we are at negative 1/2, and at 2 pi, back to 0. 13 pi over 6, we're at 1/2, that's our coterminal angle. We're repeating our values. At 5 pi over 2, we're up to 1. 17 pi over 6 at 1/2, and at 9 pi over 2, did I do that right? 540, sorry, this should be 3 pi. My bad. Should be back at 0. Sorry about that. All right, so now that we've got those plotted, we're going to connect them with a smooth curve, as smooth as I can draw. Need to expand my window. There we go. And hopefully you can kind of guess what's going to happen from here. We're going to go down and start repeating that same pattern. We could go in the negative x direction here. Of course, that would mean the clockwise rotation. And our pattern would continue this way. So this is the sine curve. You'll notice it starts at 0, 0. We go up first to hit our maximum value. Once we're back at the midline, we go down to hit our minimum, and then we come back up, and that whole thing takes 2 pi, one rotation around the unit circle. So here are the questions we want to be able to answer. What is our y-intercept or starting point? When we go to graph, we need a place to put our pencil first, and that point is going to be 0, 0, and I'm going to write that that is at the midline. What are the x-intercepts? Where do we cross the x-axis? We know that the y value would be 0. So if we look back here, it happens at 0 and pi and 2 pi and 3 pi, and then we would guess that the next one is 4 pi and 5 pi. So we can find an x-intercept at any multiple of pi. A good thing to note is that we get an x-intercept halfway through the cycle. Maximum value, how high does our graph go? We know from the unit circle that it cannot go any higher than positive 1, and it cannot go any lower than negative 1. That maximum value happens at pi over 2, and the minimum value happens at 3 pi over 2. And if we go back and we look to see where that would repeat, the maximum value here, do this in another color, is at pi over 2. And the next maximum is over here. How far is it between pi over 2 and 5 pi over 2? This distance is 2 pi, one complete cycle away from each other. So we could also say it's at pi over 2 plus 2 pi n. Every time we go a full 2 pi away from that, we're going to be back at a maximum value. The same is true for the minimum because it's going to keep repeating. Every time we go through a full cycle, we're going to be back at that minimum value. What is the midline or axis of the graph? Well, just for the basic sine graph, that's right in the middle. It is the x-axis. That's a horizontal line, so we can say y equals 0, horizontal line. What is the period of the graph? How long does it take to repeat all of its values? That is one trip around the unit circle, and since we're in radians, we're going to call that 2 pi. Amplitude. Remember that amplitude is the distance between the midline and the maximum or the minimum. So amplitude can either be here or amplitude can be here below the midline. Either way, that is a distance of 1 unit. It is always positive. So this is a graph where we can look and say that the amplitude is 1. Now we did have a formula for that. If we want to find the amplitude of the graph, we would do max minus min and divide by 2. On our graph, our maximum value is 1. We're going to subtract our minimum value of -1, which gives us 2 over 2, which is 1. So that's how we could use a formula to find amplitude. Midline of the graph, we want to split it in half into its upper and lower halves, and that's y equals 0. We want to see that we can get that same equation by doing max plus min divided by 2. 1 plus -1 divided by 2, just like a midpoint equation, gives us 0 over 2 or 0. So the middle of the graph is 0. Domain. You'll remember those are our x values. And our graph stopped, but it didn't have to. We could keep going around and around and around the unit circle and keep adding on more and more radians. So the domain of the graph we can express as all real numbers, -infinity to +infinity. The range of the graph, now that's restricted. We don't go up to +infinity or -infinity. We go up to 1 and we go down to -1. And those are included values, so we could express that with an inequality as y greater than or equal to -1 and less than or equal to +1. If you prefer set notation, interval notation, excuse me, -1 to 1, inclusive, so you're going to use the square brackets. And as we go to graph sign, the things that we should know about before we start manipulating the graph this week: periodic with a period of 2 pi, that's how long it takes to repeat. The x-intercepts are at multiples of pi. The y-intercept is 0, 0. The starting value is at the midline, and we go up to 1 and we go down to -1. This is a quarter of the way through. And our negative value is 3/4 of the way through our period. Our domain, all reals, and range, -1 to +1. So learn the basics of this curve so you can sketch this from memory before we start to modify that with all of the transformations that we've done for every other graph this year.